This video is going to show us how to multiply using partial products. There's lots of ways we can multiply large numbers and different strategies that work better for certain students. This is just one strategy that we're learning called partial products. In order to fully understand what this means, we first have to understand some math vocab. So I'm going to review that. Some of the math words we need to understand during multiplication are factors, product, and partial product. So when we have a multiplication problem like 3 times 8 equals 24, the factors are the numbers we're multiplying. So we're multiplying 3 and we're multiplying 8. So factors are the numbers we multiply to get our answer. In math, the answer has a fancy name. It's called a product. So the answer to a multiplication problem is called a product. So the product is 24. The answer is 24. Down here for 6 times 7 equals 42, the product is 42. That's the answer. So whenever we're talking about the product, it means we want the answer. And we're going to be focusing on a strategy called partial product, which means part of the answer. We're getting parts of the answer to finally get the full product. So here we go, multiplying using partial products, where we're gonna get parts of the answers first. So if I have a problem like 4 times 386, for some students this larger number is hard to kind of work out. So what we end up doing with partial products is turning this larger number into numbers that are typically easier to work with, which would be numbers that end in zeros, because we've practiced how to multiply by tens, hundreds, and thousands in a faster way. So what we end up doing first is take the bigger number and break it up into its expanded form. So this number has 3 digits, 3 parts. So my model that I'm going to use to help me out will have 3 parts. 386 broken into expanded form is 300 plus 80 plus 6, which we practice in chapter 1. If you read this number, it helps you out. So 386, 386. For students that don't remember how to read the numbers or they struggle with that part, you can always write the number down, and then you take the first digit, bring it down, things behind turn into zeros, bring down your second digit, things behind turn into 0, bring down your last digit. There's nothing behind, so that's it. So we have the pieces, 380 and 6. Okay, so we have expanded this number to end in zeros. And we're still multiplying by 4. So 4 times these pieces. And what we end up doing with that number 4 is called the distributive property. We are distributing that 4. So we're going to end up doing 4 times 300, 4 times 80, and 4 times 6. And if you remember, when we have these zeros at the end, we can use that fast strategy where we ignore the zeros and just do the basic math fact, which would be 4 times 3. 4 times 3 equals 12. Those 2 zeros I ignored, I can now put them back in. So 4 times 300 equals 1,200. Now for my next time, for 4 times 80, really I'm going to do 4 times 8. That's the basic math fact, which is 32. And that 1 0 I ignored, I'm going to put it back in. So 4 times 80 equals 320. Then my last partial product, 4 times 6. 4 times 6 is 24. I didn't ignore any zeros here, so it's just the product of 24. Now you'll notice I got an answer here, an answer here, an answer here. Each of these answers is a partial product, meaning it's part of the answer to the real problem. We broke it up here, we need to put it back together. And when we put things back together, we add them back up. So 1,200 plus 320 plus 24. If we put that all together, we should get the final product, the final answer to this problem. And just a quick hint and reminder, when you're adding, you need to make sure your numbers line up by their place value. So you need to start from the back, make sure everything lines up nice and neat so that you get the correct answer. So our final answer would end up being 1,544. So 4 times 386 equals 1,544. Using partial products as our strategy. Okay, I'm going to give another one, and you try to do this by yourself. Pause the video and see if you can figure it out using partial products. So let's say this is your problem. 3 times 97. So you should have drawn your rectangle. You're going to break down this number, figure out how many digits. It has 2 digits, so we break it up into 2 pieces. And we do that in expanded form, which would be 90 plus 7. We're still multiplying by 3. And now we need to distribute that 3. 3 times 90 and 3 times 7. For this one, I can do the basic math back. 3 times 9, which is 27. Put in 1 0. For the next one, 3 times 7, that's 21. There's no 0 I ignored, so that's it. Now put the pieces back together. 270 plus 21, which equals 291. Okay, so the product, the final answer would be 291. Now that one I kind of did, so this one, try to do it yourself, pause it, solve it. Sometimes the number is only 2 pieces, sometimes it's 3 pieces. Depending on how long the number is, that's how many pieces your model needs to have. So let's say you have 7 times 498. Okay, so here's where you would pause the video, try to solve it by yourself using partial products. Okay, now hopefully you paused it, you solved it, and now you're just checking your answer. Okay, so model, we're breaking down this number to be easier with expanded form. It'd be 400 plus 90 plus 8, because that's 498. We're multiplying still by 7, so don't forget to put the 7 on the side. And that we're multiplying. And now we're going to distribute the 7. 7 times 400, 7 times 90, and 7 times 8. And when you do these, you do the basic math back first. 7 times 4, 28, 2 zeros. 7 times 9, 63, 1 0 ignored. 7 times 8 is 56. We didn't ignore any zeros there. We added up. 2,800, 630, 56. I lined everything up from the back. And now I just added up. Notice I have to regroup right here. And our answer ends up being 3,486. Okay, so hopefully you're able to do that. I'm now going to show this last part. This last part's just to see how does this partial products model kind of relate to the other strategies. So this is just kind of like a bonus thing for you to think about. So I I showed you partial products. I'm going to talk about the expanded form for solving this type of problem, which is really complicated, and regrouping, which is usually known as a standard algorithm for multiplying. So for our example, I'm going to have the same problem for all of them. I'm just going to use a different strategy. So our problem, let's say it's 3 times 164. So 3 times 164 and 3 times 164. If I'm doing partial products, I break that number up. 100 plus 60 plus 4 times 3. When I do my partial products, I get inside 300, 180, 12, and then I add it back up. Okay, for a final product or answer of 492. When I'm doing this expanded way, which is, it shows mastery of equations and understanding where all these pieces come from. Partial products, this strategy is a more simplified version of understanding these numbers. It takes a little longer, but most students tend to get this strategy. So let's see expanded form. Here I take the number 3, I'm still going to multiply it, and this 164 I'm going to use expanded form like in our model, which would be 100 plus 60 plus 4. Notice now it's just represented within the parentheses. And like before, we're now going to distribute that 3 to each part so that we get the equation looking like this. 3 times 100, that's one part, plus 3 times 60, that's the next part, plus 3 times 4. That's the last part. Now we're going to find the actual partial product for each part. 3 times 100, look, it was 300, plus 3 times 60, which we already know is 180, plus 3 times 4, which we figured out over here was 12. If we add it all together, it's the same thing we did right here for a final answer of 492. And lastly, this is not the only other strategy, there's a bunch, but regrouping or standard algorithm. For this one, we'll do 164 times 3, and usually it's set up this way, stacked, and we do this way. 3 times 4, which is 12. Put the 2 here, we regroup the 1. Then we do 3 times 6, which is 18. Since it's in the tens area, it'd be 180 actually, but we think of it as 18 plus 1 more is 19. So we're going to regroup that. The 9 goes down here, the 1 goes up here. 3 times 1, which is really 3 times 100, would equal 300, but we think of it just as 3 times 1. 3 times 1 is 3, plus 1 more is 4. And we get 492. Notice that the answer is the same regardless of what strategy you use. Some students like this one. It's faster as long as they can remember each step. I don't know too many people that like this strategy, but if you like it, use it. It shows a really strong understanding of equations, distributive property, lots of good things out of using this strategy. But it takes a really long time. And some students like partial products. Models tend to make things easier to really understand where they're coming from. Okay, but regardless of the strategy you use, you just want to make sure you're getting the right product at the end. And in class, we're going to focus mainly on partial products and sometimes regrouping.